Looking at this model of a healthy Active Directory forest, you can see continuous dynamic synchronization. Hundreds of domain controllers are constantly talking, pushing, and pulling directory updates across the network to keep the environment perfectly aligned. But this massive web of communication relies entirely on a single specific structural component to function. Somewhere in this topology is a DNS server that is authoritative for the _MSDCS zone of the forest. If you take that specific zone offline, or if the DNS server hosting it becomes unavailable, the system doesn't gracefully degrade. The replication links immediately sever. Every domain controller in the forest goes deaf to its partners, isolating the nodes and halting all directory synchronization instantly. Active Directory relies entirely on this specific zone for forest-wide synchronization. To understand why a massive, decentralized directory service has such a strict structural dependency, we must look at how domain controllers actually find each other. It is a logical assumption to think that domain controllers simply ping each other's standard hostnames or IP addresses to sync data. Standard A records map a hostname directly to an IP address, but physical network locations shift. IP addresses change. Even the names of the servers themselves can be altered during hardware migrations. Relying on hostnames makes the replication topology fragile. Active Directory requires an immutable identity. It needs a system that prioritizes a permanent mathematical identifier over a temporary physical network location. A robust directory replication map must survive server renames or total infrastructure shifts without breaking the synchronization links. Standard hostname resolution cannot guarantee this permanence. Instead, Active Directory uses a hidden translation pipeline built entirely on permanent identities. To find that permanent identity, we need to look past the wide network topology and examine the internal architecture of a single domain controller. Inside this schematic, the core engine managing the directory on this specific machine is the Directory System Agent, or DSA. The exact digital representation of this DSA is the NTDS settings object, specifically designated as class NTDS DSA. This object is generated the precise moment Active Directory is installed on the server. It remains active for the entire lifespan of the server's role. It is only destroyed if Active Directory is completely removed to demote the machine back to a member server. The NTDS settings object is the permanent bedrock anchor for the server's directory role. It remained constant, completely independent of whatever the physical server happens to be named. Attached directly to this NTDS settings object is an attribute called the object GUID. This string is the immutable DSA identifier. It uniquely identifies the domain controller and serves as the absolute target for any partner attempting to initiate replication. There is, however, a second GUID stored on the NTDS settings object, which often creates confusion in network engineering. This second identifier is the invocation ID. It is the GUID assigned to the Active Directory database itself. The DSA uses the invocation ID strictly for version control. It exists solely to identify specific versions of the directory database after a system restore occurs. The invocation ID plays no role in partner discovery or replication routing. The object GUID is the definitive identity guaranteed to locate the correct domain controller. The next step is broadcasting that identity out to the network. Bridging the gap between the internal database and the external network requires the Net Logon service. On every domain controller, the Net Logon service acts as the engine responsible for the DNS registration process. Net Logon registers a canonical name, or CNAME, resource record. A CNAME record functions as an alias, mapping one domain name to another. To construct this alias, Net Logon takes the raw object GUID and places it at the very front of the string. It then appends _MSDCS.DNS forest name directly to that GUID. This highly specific, dynamically constructed alias maps directly to the DNS fully qualified domain name of that specific domain controller. By wrapping an unchanging internal identity inside a standard DNS alias, Active Directory connects its mathematical identifiers with the fluid routing of the network. We can now look at the exact moment a domain controller needs to trigger a replication event with a partner. Replication initiates in two ways. A source domain controller sends a change notification outward, or a destination domain controller initiates a pull to retrieve data inward. In both cases, the controllers consult internal topological maps to find their partners. These maps are the reps2 and reps_from attributes. The source domain controller retrieves partner data from the reps2 list to locate where it should send outbound notifications. The destination domain controller retrieves data from the reps_from list to locate the inbound partners it needs to pull from. Neither of these lists contain network IP addresses. They only contain the exact GUID-based DNS aliases that Net Logon constructed earlier. Domain controllers only know the mathematical alias of their partners. They are entirely blind to the physical network until they query DNS. The initiating domain controller takes that GUID alias and sends a query to the DNS server, targeting the _MSDCS zone. The DNS server processes the request and locates the matching alias record. It then responds by returning two distinct pieces of data simultaneously, the CNAME resource record and the host A record. The host A record contains the IP address. The domain controller uses this to physically route the connection to the destination machine over the network. The CNAME record fulfills a secondary, strict requirement. The initiating domain controller reads the alias data to securely authenticate its replication partner. Replication can only begin once both requirements are met: physical routing via the A record and identity authentication via the CNAME record. This entire routing system, linking immutable directory identities to physical IP addresses, occurs strictly inside the MSDCS.DNS forest name zone. Routing by identity rather than location allows Active Directory to effortlessly survive hardware migrations and server renames, but it firmly cements the MSDCS zone as the absolute non-negotiable dependency for forest-wide replication.